Good morning, students. Welcome to the physics class. Today we are going to study about one of the important the lesson termed as an what here? The electromagnetic induction. So this particular concept is there in the what here? The magnetic effect of water, the electric current itself. So before we going to discuss about the electromagnetic induction, we need to study about one simple experiment. So here we have the one experiment. So this is a solenoid. You already know the meaning of the solenoid. You can take any plastic or a wood or a paper, make into what here as simple as cylinder, and having a what here the number of what here the copper turnings on it. So this is behaves as a what here the solenoid. This is the solenoid here. It has a number of rotation of the what here the copper coil, and this one is connected to where it is a galvanometer. This is the galvanometer. A galvanometer is one device which is used to identify, find the minute current. A small current is produced in it. That is what we term as the galvanometer. So it is just a device. So that is connected here. So you already know that this is the magnet, and this is the north pole of a magnet. Just I will mention the north pole, and here is the south end of the magnet. If we keep a solenoid under what here a magnet, little bit away from each other, there is no deflection is there in the galvanometer. In the first case, what happens? So the magnet and the solenoid is kept away from each other. There is no deflection. There is no deflection. No deflection. No deflection in the water in the galvanometer. Now what you have to do is just move this particular magnet towards the water, this coil, or we can do it, push inside that what the coil. Both things are happens. Okay, you can pull this particular magnet inside the coil, or you just keep the magnet. Let us consider here is the magnet. Okay, we have a magnet here. Let's consider. So this is the solenoid. Just this much. Okay, just. So if you do like this, so then what happens? The galvanometer shows right deflection, and the north pole is moved towards the water. The solenoid, the needle of a galvanometer is moved towards the water, right. Move towards the right. So it means that what is the second thing? The magnet move towards solenoid. Then what happens here? Whenever it is a move towards the water, the solenoid. So then what happens? The needle shows, the galvanometer shows right deflection. Right deflection. So right side what happens? It is deflects. Now let us understand the point. Okay. Whenever it comes here, then it stops. There is no velocity for this magnet. Then what happens in the third position? The galvanometer comes to the what here? Same position. There is no deflection. No deflection. So just here's the magnet. Just push this one. There is a deflection towards the right. And if you stay here itself, there is once again it comes to the what here? Same position. Now what you have to do is, in the fourth thing, it is moved towards. Now what we have to do? Drag that magnet away. Drag that magnet away. So from here to here I am. So then what happens? So magnet move away from solenoid. Then G, what happens to this galvanometer? The galvanometer needle is a shows of what here? The left deflection. Galvanometer shows or moves towards what here? Left deflection. It is moved towards the what here? The left of the. Now let us consider in a fifth case what you have to do is change the polarity of this the magnet. Northeast becomes a south and south becomes a north. Then what happens? Then if you push this the south side of the magnet, reverse this particular magnet and then push this one. So what happens here? Galvanometer that shows what here? Towards the what here? The left deflection. It means the opposite deflection. If you change the polarity, change the polarity, the deflection also what happens? Also changes in the sense it is in opposite direction. So what is the meaning thereby? So why there is a galvanometer that shows a deflection? It shows a deflection because there is a what here? The EMF. So there is one word is there that is termed as a what here? The EMF. That is nothing but a what here? Electromotive force. So in that particular coil there must be a electromotive force is produced. How to increase this electromotive force? It means that there is a production of a what here? Current. There is a current, so that is why there is a deflection. When it will not moves, there is no deflection at all. Whenever there is a magnetism move towards the quadrature coil, or there is a relative motion between the magnet and also the what is the solenoid or a coil, then there is a what here? EMF is the produced in the coil. That is termed as an electromotive force which is produced in the coil. So how to increase this electromotive force here? So we have to, what is the conclusion? What is the conclusion of this particular experiment? The first conclusion is like this. Okay. Whenever there is a relative motion between the what here, the coil and the magnet, there is an what here? The current will be produced or EMF will be produced. When there is motion between or relative motion between what and what? Between coil and magnet. There is an what here? EMF is produced in the what here? Coil, in the conductor. How to increase this EMF? We have to increase this EMF. Number of turns of this coil is increases. Increase number of turns. Increase the what here? Number of turns in the what here? Coil. Or another one is considered as use a powerful what here? Magnet. We have to use a very strong magnet. Then I can able to increase the what here? The EMF which is produced in the what here? In the coil. So this particular experiment leads to what here? The meaning of what? The electromagnetic induction. So what is the meaning of this electromagnetic induction? So electromagnetic induction is whenever there is a change in the number of magnetic field lines. Why there is an EMF is produced? Because around this there is a what? Number of magnetic field lines which is there. Whenever you push this magnet inside, there is a what here? Change in the what? Magnetic field lines. Because there is a change in the magnetic field lines, the EMF is produced in it. So therefore, I can able to define the what is the meaning of electromagnetic induction is there. Whenever there is a change in the number of magnetic field lines linked with the what here? A conductor. An EMF is developed between the ends of a conductor, which lasts as long as the what here? Change takes place. This is known as what here? Electromagnetic induction. So just I will write this one. Whenever there is a what here? There is a change in. There is a change in the number of magnetic field lines. The number of magnetic field lines. Where it is linked? Which is linked with the water conductor. Linked with conductor. Linked with conductor. Which produces a what? Which produces an EMF. An EMF is developed. And EMF you already know that. Electromotive force. Okay. Force. Developed. Where it is developed? Between the what here? Ends of the what here? Conductor. Developed between the ends of conductor. So when it will lost, whenever this relative motion stops, whenever it stops, here it will stop, so then it becomes a what here? Nullified. It becomes a zero, which lost as long as the changes takes place. Which lost as long as changes takes place. So this is what we termed as electromagnetic induction. This leads to what you have, Faraday's. Thank you for watching this video. Thank you very much.